Okie dokie, let's have a little look at 9 then. There's one thing to say here about 9 is you've got to look at these things. This is a order 2 on the top because the highest power is x squared, isn't it? And the bottom one, the highest power is x cubed, so that's of order 3. So this is a proper partial fraction. We could proceed with using the rules, couldn't we? But you'll notice here this is a quadratic and it factorizes. And if you've seen the the other section on factorizing quadratics, you'll easily spot there that that can be written as x plus 4, x minus 4. Well, there's an x plus 4 on the top, you see. So why don't we just simplify the thing before we use partial fractions, because that's a common sense thing to do, isn't it? So we've got x minus 3, we've got x plus 4, then we've got x plus 1, and as we said, if we can factorize this, which we can, to x minus 4x plus 4, then we can cancel like we would do with any other fraction what is common top and bottom. So we've simply got this then, haven't we? So basically we're dealing with this problem. X minus 3 over x plus 1 and x minus 4. So we can use linear factor, simplest of all methods to solve this problem. So let's have a look at that then. Here it is here. A over the first plus b over the second for linear factors. So that will equal to 2 then, a over the first plus b over the second. There we go. Multiply through by, so we used case 1. So I'll put that in just here in a bracket. Whoops. And I'll also say what we're doing now. We're going to multiply by the denominator. Okay, both sides. So multiplying by this on this side, they'll cancel and we'll just be left with what's on top. Multiplying by these two on this side then, for the first term, the x plus 1's cancel and you get a x minus 4. And then the b, and this time the x minus 4's cancel, and you'll have x plus 1 on the top. There we go. Now look at this. Which convenient value should we put in? Well, clearly at 4, this will go, and this will go at minus 1. So it's much of a muchness. So I think I'll put in 4 here, yeah? And let's see what we get. 4 take 3 is 1. So we're going to sub in this, and we get 4 take 4 is 0, so that would be a times 0, which is 0. And then b times 4 plus 1 is 5, so it's 5b. So 5b equals 1 then. Divide by 5 both sides, or move the 5 from times to divide on the other side. And you can see that it's a fifth, can't you? Yeah? Okie dokie, that's good. Now the other value that we mentioned was minus 1, so let's just mention that here. We're going to substitute this value in. X is minus 1. Minus 1 here then, put it into this line. Minus 1, and then take another 3 away from minus 1, you get back to minus 4. Minus 1, take 4 is minus 5. Minus 5 lots of a's is the easiest way to write it round. Minus 5 lots of a. And then minus 1 here times plus 1 is 0. 0 times b is 0. There we go. That then implies we can minuses cancel. The 5 can go from times to divide. Writing it down from right to left, a equals 4/5. There we go. That's that one done. Good. Nice. So then y equals, and we can write down the answer, can't we? A, which is 4/5. Drop the 5 down to be with what's underneath, which is x plus 1. Yeah. Plus b, 1/5. Drop the 5 down again to be with the x minus 4 that's there. That's it. That's the partial fraction for question 9. A lot easier, wasn't it, than what we might have envisioned had we just proceeded without just taking a moment to think about the problem. So it does pay sometimes just to take a glance, look, see if there's any common factors top and bottom that we can divide out. Okay then, let's move on to the next one, number 10. Great.